Okay, so now we are doing number 6A. I decided to make a new video so it would be a little bit more organized. Aha, okay, just making sure that this is working. Let me clear this out and let's get in our problem. Our problem is negative square root x plus 9 minus 72. So negative, that's not the negative square root of x plus 9. Now that's going to be a problem for us actually. We'll see why in a second. I think that's minus 72. Okay, so let's go and do minus 72. Okay, let's hit graph. Now the problem is I'm not going to see the graph very well. The reason I'm not going to see the graph is because that minus 72 is a big, big number. So what I'm going to do is I'm going to do zoom. I'm going to go fit. Fit is down at the bottom. I could do zoom out. That would work. Zoom fit will automatically find the graph. So let's go ahead and see. Let's see. The graph's going to find it. Oh, look at that. That looks beautiful. That looks great. So that's what the graph looks like. Now I need the domain of this thing. Let's see here. This is probably not the best way, but let's find it anyway. I'm zooming out just to see where the graphs are. Whoa. Okay, so I zoomed out just once, and it looks like the graph just starts here. If I do a trace, it looks like the graph starts at negative. Oh, no, it doesn't. Let's see here. Let's go to second graph. I'm pinning up the table because I want to see where that graph starts at. Oh, this is what I want. So at negative 9, it looks like that's where the graph starts. Okay, we could have gotten that by looking at this anyway. This graph moves right, moves left 9, and down 72. So because the graph moves left 9, and we usually start at 0, 0, that means that our domain, and down 2. Hold on, let me catch up here with my thoughts. Okay, so down 72, left 9, we're good. All right, so our domain then means that we start at negative 9 because we went left 9, and that's what the graphing calculator is verifying for us. But the range, well, I'm sorry, the domain, the other half of the domain is infinity because the x value goes on forever. So I'll repeat that because I kind of stumbled upon that. I kind of struggle with that. So again, we had a negative 9, which is the starting value. Then all these other x values get larger and larger and larger, which means we're going to positive infinity for the x values. So brackets, parentheses. Let me just make a little note here. We use brackets for starting point. So brackets for starting for an actual point. And use parentheses for a non-existent point. Like that 0.8 on there. Okay, so we have that now. Our range is going to be starting from the lowest y value to our highest y value. So I'll show you a little bit more direction on this. Our range is going to be our low y to our high y value. Okay, so let's look at our range here. Looks like our graph has our low, well, these are all lower y values, and it looks like this y value keeps going down, 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 down. So it looks like the lowest y value is negative infinity. But it goes up, 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 up until about negative 72. And just looking at the table, that kind of verifies it for us. Negative 72 is the biggest number here. And then these y values keep getting lower and lower and lower and lower. So let's going to go back here. Our lowest y value is negative infinity because there was like no actual low y value, just the graph kept dropping. The highest y value was negative 72. domain and range for this one. For the other one, let's see what that graph looks like. 3 square root of negative x plus 7. So 3 square root of negative x plus 7. Okay, let's graph that. Now, we could actually get let's do a zoom standard here, just so we can see a much better graph. Okay, well, there it is. Let's go to a table and see what's going on here. Holy moly, that's a lot of errors. Let's see what's going on here. Let's go up and see what's going on here. Hey, there we go. Okay, so there's the starting values. So it looks like my graph, it looks like all these negative values for x occur until you get to 0. So it looks like my domain for this one is going to be negative infinity, because that's my lowest x value. And my highest x value looks like it's 0. And remember, we're going to use brackets for the numbers, because that's an actual number on the graph, parentheses for the x value. Okay, let's do the range. The range is going to be, now it looks like we start at 7, and now it looks like the y values keep getting bigger and bigger and bigger. So it looks like the lowest y value is 7. So lowest is 7, highest y value. Lowest y value is what I meant here. So 7 to infinity, parentheses on infinity, brackets on the actual number. There's my answer. That took 7 minutes, so now let's catch up on time. Look, there's my answers. Oh, and it just said the domain. Ha! Didn't read the instructions, but there's your range anyway if you had some hard time with that. Let's do 7a and b and pick up some speed here. So we got a 4th root of 10 times the 4th root of 375. Because we have the same roots, we can multiply these numbers together. If you weren't sure about that, you can change this into exponential form, exponent form, and multiply these together. You get 3,750 to the 4th, or if you want, you get 4th root of 3,750. And now it's going to be a lot of dividing. 4th root numbers in your Powerful Number booklet are numbers like 16, because that's 2 to the 4th. There's 3 to the 4th, which is 81. There's 4 to the 4th, which is equal to 256, I think. So all of these numbers are in your Powerful Numbers booklet, and we're looking for one that goes into 3,750 evenly. So let's see what we got here. Let's go ahead and let's quit this. Let's do 3,750 divided by 625. Wow, that was luck. That was luck. Okay, so I found out that we have 6. I found out that we can actually do the 4th root of 625 times 6 gets you 3,750. Or what I did in my class was we broke this 3,750 into 2 numbers, 625 to the 1/4 times 6 to the 1/4. Either way would be fine. I'm showing you both ways because maybe your class did a different way. We found that the 4th root of 625 is 5. The reason I know that is because 5 to the 4th is 625. So the 4th root of 625 is 5. If you weren't sure of that, in my class what I was doing is I did this, and I needed 4 numbers that multiplied together to get 625, and all I needed was just one of them. Okay, so however you think of that is totally fine, but we got 5 on the outside, and the 4th root of 6 stays. So the 4th root of 6 stays, and that's how you get your answer. And let me just color code a little bit here so that way you know where I got this from. The 625 1/4 was all here in either form that you did, and the 6 to the 1/4 is right here no matter how you looked at it. Okay, that's your answer, 5 times the 4th root of 6. Let's go on to the next one. Okay, the 5th root of 243. Well, lucky for us, I think that's in our Powerful Numbers booklet. We need 243 to the 1/5, which is going to be, let's see here. I believe that's 3. And it looks like we only need one of these. Okay, so since we only need one of these, we'll take one on the outside. So that we got 3. Now, let's do exponents. Let's do 10 divided by 5. That's 2. So we have m squared. Let's do 7. 7 divided by 5. Well, 7 divided by 5 goes in once, but with a remainder of 2. So what that means for us is we're going to have a y to the first. The reason it's to the first is because that's how many I was able to take out. Okay, and now we also have 2 left inside. So let me set up my root. Okay, and we have 2 y's left inside. And here's where I got that 2 from. I got it from that 2 right there. And now let's do z. The z to the 4th, well, that's going to be a nicer one because a z to the 4 goes into 5 0 times. So there's nothing I can take out. So this last one is just z to the 4th. And that's my answer. Let me just move this over because that is the answer altogether. Okay, let's keep going here. Number 3. Okay, let's do 128 to the 1/3. Oh, yeah, these are hard. All right, let's do 128 to the 1/3. So I need a number that's multiplied out 3 times. So that could be like 8, because 8 is 2 to the 3rd. Or it could be 27, which is 3 to the 3rd. Or it could be 64, which is 4 to the 3rd. Could be 125, but I think it's 64. I believe 64 and 128. I believe 64 times 2 is 128. So the 3rd root of 64 times 2 is 4 times the cube root of 2. A different way you could have done this is 128 to the 1/3. And seeing that you could break that up into 64 to the 1/3 times 2 to the 1/3. 64 to the 1/3 is a number times a number times a number, and only taking one of those. However your teacher explained it to you, you should be able to get this 4 and be able to see why there is a 2 left over. And now let's deal with numbers. Now, I'm going to do a fancy trick here. That cube root of x squared over the cube root of x to the 8th can be rewritten as x to the 2/3 minus 8/3. Why am I allowed to do that? Because if I have, nope, that's not it. Let's see where it is. I can subtract exponents when I have 2 bases that are the same. And my 2 bases are x and x. So I can do that. I can subtract the exponents, so I get x to the negative 6 over 3, which is x to the negative 2, which is actually 1 over x squared. Well, that was going to be pretty straightforward then. So all of this is divided by x squared. There you go. Let's do D, but I'm going to duplicate this and clear it so that way it's a little bit easier to read. Do this. Okay. So let's do D. We have 9 times the root of 28x to the 11th minus x to the 5th. Okay. Okay, let's simplify root 28 first. Root 28, you're looking for a number, a square number, like 4 and 7. The square root of 4 is 2, so you have 2 root 7 for the first part. That's for the 28. The 9 is going to multiply that. So it's going to be 9 times 2 root 7, which is 18 root 7. The x to the 11th, so remember there's an invisible 2 here. So let's take 11 and divide it by 2. 11 divided by 2 goes 5 with the remainder of 1. So that means I can take 5 x's out, but 1 x is left inside. Okay, next, our n is only one n, so we have to leave that inside. Okay, that's the first part. Minus. Okay, so now we have minus. This part didn't change yet, so let's change it. Root 448. I'm looking for the biggest perfect square that goes into it. I think, I'm thinking, I actually don't know that one off the top of my head. Let's see, 448. I have a calculator. Let me just use the calculator. So I'm looking at these numbers, by the way, before I do that. To simplify root 448, I'm looking at numbers that are squared, like 16, 25, 36, 49, 64, 81, 100, something like that. So let's see what 448 is divisible by. Okay, so let's clear this. Okay, that's good. 28 looks like it can be broken down though. So I'm going to keep dividing by something even bigger. Let's do 64. Oh, okay, and 7 is a nice number that can't be simplified, so let's do 64. 64. So the root of 448 is going to be root 64 times 7. The square root of 64 is 8. So we have minus 8. 7 is on the inside. 64 is on the 8's on the outside because the square root is 64. And x and n are both to the 1 power, so we have to leave those inside. Now there was this x to the 5th, so let's put that with the 8. And now we can see that we have 18x to the 5th minus 8x to the 5th. And the thing inside the, this part inside the root is exactly the same, which means we can subtract the numbers on the outside. So what we're going to get is 18 minus 8, which is 10, x to the 5th, and then root 7x to the 7xn. Hey, tough problem, but thankfully we have our conjugates to help us. 8. All right, multiply by root 7, top and bottom. If you want to multiply by negative root 7, top and bottom, either one would be fine. And we get negative x root 7 over root 7 times root 7 is going to be positive 7, negative and negative make a positive. So we just move the negative on top. For b, we need a conjugate. The conjugate is going to be basically the same numbers, but with a subtraction sign on top and bottom. And now, let's go and distribute. So we got negative 2 times negative 7, which is 14. We got negative 2 times negative root 6, which is positive 2 root 6. And then, because we're multiplying by the conjugate, we only need to multiply the first numbers and the last numbers. So the first numbers are going to be negative 7 and negative 7, which is, when you multiply them, you get a positive 49. And then we also get a root 6 times negative root 6. And root 6 times negative root 6 is minus 6. And if I subtract the bottom, I end up getting 43. And that's my final answer. Nothing else I can do. I can't add the top because there's no common, there's no like terms. Okay, last one. We have 2 root negative x minus 3. Let's stop this here and upload it.